Hello everybody, welcome to my optional mathematics class. Today I am going to solve a problem. The problem from trigonometry, but I will just not prove it or just not explain you that how to solve it, but I will also suggest that how if you do a single problem in different ways, then how you feel that you have gained your confidence in solving the problem independently. Alright, so my suggestion will be to while especially in the practice mode, this is good idea to do the same problem in different way so that we can fully understand the extent of its solution. So let's share the screen. So for example, if you are asked to prove that 1 minus sine 2 theta divided by cos theta equals to 1 minus tan theta 1 plus tan theta. So in order to work with full confidence, try the same sum in different ways, especially while you are in learning process. But in exam, don't try in different ways. Okay, you should be fully prepared for the exam and then try the way you are fully confident. Alright, so let's now try to solve this question. So first way, what I will do, actually I will start from left side and I will then go to the right side. Then I'll see that if there is alternative method to prove that this sort of sum also. So here in this case, we start from here. So we can just write LHS, or you can say that it is here. It is given that 1 minus sine 2 theta by cos 2 theta, and if you like you can call it as LHS. That means this is left hand side. And now you know the formula for sine theta in terms of tan, because you have to get the left side in terms of tan theta. So if you know it is sine 2 theta, there are a lot of formula regarding this. It is 2 sine theta times cos theta, but here in this case, as we are going to express that in terms of tan, so we should apply sine 2 theta in terms of tan. So it is found that it is 2 tan theta divided by 1 plus tan square theta in form of tan. And also you can see here in the denominator there is cos 2 theta, then you have to use that formula also in terms of tan, and we know that cos 2 theta in terms of tan is 1 minus tan square theta over 1 plus tan square theta. So now what you can do, you can say this is LHS if you like. So you start from here, this is L H S, or you can just write over like here and then take this left side or right side also, it is possible. So you will take this here like this, LHS, but at this time we are going to prove LHS equal to RHS. So in the LHS you can see that this is 1 minus sine 2 theta over, you can see this is cos 2 theta, so here it is cos 2 theta. Now as we are going to represent this sort of, we are going to prove this sort of thing in the term of tan theta, so definitely we will apply the formula for sine 2 theta as well as the formula for cos 2 theta in terms of tan. So after this step, what you can write here, that this is 1 minus, and sine 2 theta means we put the same sort of formula like this. So it is 2 tan theta in place of sine 2 theta is, and this is 1 plus tan square theta, and then in the denominator we can see there is cos 2 theta, sorry, this is cos 2 theta, and cos 2 theta in terms of tan is, so that we can write in place of cos 2 theta as 1 minus tan square theta plus 1 plus tan square theta. So now we can go further. Now there is a matter of algebra than the matter of the trigonometry. So in this case, while working, your equal should be just below this equal, but I require some place, so that I start from here, and then this is the part, and then now we can take upside the LCM of upside means it is the numerator part I am talking of. So LCM of this sort of thing is 1 plus tan square theta. So this time we are not applying the things for trigonometry. In fact, we are doing the algebra. So that there is 1 by 1, so that it will be here 1 time. If you know the process of algebra, then it will be here 1 times of 1 plus tan square theta. So we write here 1 plus tan square theta for this tan square theta, and minus it is remained with here another side, it is 2 tan theta. So you only require the algebraic skill over here, and we need to do nothing at this point. So we can just write 1 minus tan square theta divided by or upon 1 plus tan square theta. Now compare the numerator and denominator. So what you see here is that, like, this is 1 plus tan square theta, and this is also divided by 1 plus tan square theta. So algebraically these two terms will be cancelled out, and then you will be left with here, after this step we are here. So what you can say in this case is that this is 1 plus tan square minus 2 tan theta. So it's like this. 1 means you can write 1 square, minus 2 tan theta means you can write 2 tan theta. No, or what you can do actually, this is also possible to write that 2 times of 1 times of tan theta. Alright, and after this term we are left with tan square theta here. So we put here tan square theta. Okay, you might have understood why I have expressed in this way. Alright, and the denominator, what we are left with here, 1 minus tan square theta, and also you can say 1 square, because 1 and 1 square are the same values. So here, why did you convert like this? So it looks like as if it is a square minus 2ab plus b square formula, b square term, so that you know that for a square minus 2ab plus b square is a minus b. So what we can write here, we can write here 1 minus a minus b square, that means 1 minus tan theta square, and to the down you can just compare with, this is like a square minus b square formula, and you know that a square minus b square is going to be a minus b times a plus b. So it is 1 plus tan theta, because in place of b there is tan theta, in place of a there is 1, and similar thing so are here as well. Now we can see that in the numerator and denominator, okay, this is 1 minus tan theta power 1, and then a square has been cancelled out, and then finally you have here, after this step, you can see after this space you are left with 1 minus tan theta over 1 plus tan theta. Now let's compare with the right hand side. Yes, did we reach to the right hand side as 1 minus tan theta? Yes, we have 1 minus tan theta, and in the denominator we have 1 plus tan theta, so it is 1 plus tan theta, and this is the RHS, and therefore you can say that this is proved. So even though we have proved this sort of thing, especially while you are learning the process, don't stop your process of thinking in different ways for the same problem. You can think of other sort of methods also. So at this time I can say what I will do actually is that, first of all I will take LHS and I will have one term, and then I will take RHS, then I will have another term. If I get both the terms from LHS, that is left hand side, and from the right hand side same, that means we can also say that this sort of things have been proved. So let's try in alternative way. Yes, so let's see how we can do this sort of thing, this sort of proof alternatively. So what I'm doing at this time is I'm taking LHS first of all, and then it is 1 minus sine 2 theta upon cos 2 theta. So at this point I will convert everything either in terms of sine theta or cos theta from this LHS, and I will do the same thing from the RHS as well. So let's convert that in terms of sine theta. You can try for converting everything in terms of cos theta itself. That will also be possible here. So this is 1 minus, you know that sine 2 theta formula, you should know that. That is sine 2 theta equals to, at this time you can also use, this is 2 sine theta and cos theta. You have to see that in what way we are going to proceed, and then accordingly we have to express sine and cosine. And also if you talk about for example cosine of the thing in term of sine, so what you can write here, cos 2 theta equal to either 1 minus or whatever you see. So in general you know that this is cos square theta minus sine square theta, and later on we will see that how it is going to be used here, then we can convert accordingly. So at this time what I am writing for this sine 2 theta is 2 sine theta times cos theta, and then in the denominator what I am going to write here is that cos square theta minus sine square theta. Now we know that also we also know that sine square a or theta plus cos square a or any angle theta equals to 1. So it is possible that in place of 1 you would write it is sine square theta plus cos square theta. In order to think all those sorts of things, you should have good command over this sort of formula. Alright, so in place of 1 I can write sine square theta plus cos square theta, and I'll see how it works. And then we have the remaining term as minus 2 sine theta and then cos theta over here. So this is 2 sine theta cos theta, and in the denominator what I will now do is that it is cos square theta minus sine square theta, and we should be happy at this point is that because outside you can see that it is now in term of a square plus b square minus 2ab, which is a minus b whole square. So what we could write, we can write here is that a means sine theta and minus b means it is cos theta, and then this is whole square, and in the denominator this is in the form of a square minus b square, where cos theta is in place of a and sine theta is in place of b. So what we can write here is that a square minus b square means a plus b, a minus b. So we write here cos theta plus sine theta and times cos theta minus sine theta. Alright, and you can see some. After this you can think that in the numerator this is sine minus cos, but in the denominator this is cos minus sine. And one benefit is that we have the square terms. Even though if you take the negative sign common, so a square of the negative sign is going to be positive. So this is possible to write here as, in place of sine minus cos, you can write here cos theta minus sine theta, then a square, and in the denominator we have here now cos theta plus sine theta and then times cos theta minus sine theta, and you can cancel this term and the square because they are the same terms. So it is, now it is in the numerator we have cos theta minus sine theta divided by, it is cos theta plus sine theta, and this is our LHS. Alright, now we work for RHS. Is that okay? So RHS in terms of sine cosine, let's see what happens. So we'll try to convert everything in terms of sine and cosine here. So RHS, you can see that it is given as 1 minus tan, what is this, 1 minus tan theta divided by 1 plus tan theta, and then you can write after this equal to, yes, you know that this is easy. So sine theta means in term of tan theta means in term of sine and cosine is, this is sine theta by cos theta, and here in the denominator part also you can see this is 1 plus, in place of tan theta you can write here sine theta by cos theta. Now just do the algebra, like if you are working with the numerator part, it is going to be cos theta is LCM with this part, so 1 time cos theta is going to be, here it is cos theta, and then minus it remains sine theta. So you should be properly efficient in working with algebra. So now here also we have LCM as cos theta, you can see, and then it is 1 time of cos theta. After taking the LCM it is cos theta, and then plus it is sine theta. Alright, and you can see the denominator of the denominator terms in both the numerator and denominator are the same, so algebraically they got cancelled out, and finally you have here cos theta minus it is sine theta over it is cos theta and plus it is sine theta. You can call this as 1 and this equation as 2. Now compare equations 1 and 2. Have you seen that the LHS term is equal to the RHS term here? Yes, cos theta minus sine theta, here cos theta minus sine theta in the numerator. In the denominator we have cos theta plus sine theta, here it is cos theta plus sine theta, and therefore you can say from 1 and 2 LHS equals to RHS, and hence this is proved. So although in exam you require only one method to prove this sort of thing, but in order to learn it properly with a greater confidence, you try the same problem in different ways. Here I have done the same problem in 2 ways over here. Can you now think of also the third way of doing same sort of problem? Alright, so if you can think that way, it will give you just not a better practice, but also it will build up your confidence even stronger. Okay guys, alright, hope this sort of a skill will help you understanding as to how to work with the problem solving, especially in case where there is the problem that relates to prove left hand side equals to right hand side. Okay, so this is all for now, and thank you for watching.